Today I want to show you how to solve a linear system using Cramer's rule with Python SymPy. We take a sample system like such, and we want to solve for the variables x, y, and z. As you may know, there are different approaches to do this. You can use Gaussian elimination and other stuff, but today I want to walk you through Cramer, although it's not the most efficient way to do it. So first of all, we load the variables, like define the symbols over here, x, y, and z. And then let's have a look at Cramer's rule. So Cramer's rule for a system ax equals b, represented as such, where a is the coefficient matrix, x is the vector of variables, and b is the constants vector. The solution for each variable xi is just the determinant of ai divided by the determinant of A. AI is the matrix formed by replacing the ith column of A with a constants vector B. So we take this vector here and replace one of these columns. Let's have a look at what this looks like for our system, where the coefficient matrix is this here and the constants vector is this one. We just show some simple values. We put it into SymPy and we load it over here, defining the matrix, defining the constants vector. And now let's calculate the determinants. Determinant of A is straightforward. Just take the determinant of A like this. Then the determinant of AX, replace the first column by B. So we define B as such here. And we just put it here instead of this part. We do the same for the second column and just replace it by B to get AY. And for AZ, we do the same. So just replace it over here. So in Python SymPy, it looks like such. We get the determinant, just dot determinant over here for A, that's the straightforward one. And then we replace the columns. So here we say for the 0 column, so the first column, set it to B, set the second column to B, and set the third column to B. And then when we do this and we calculate it, or we did it over here, we get these values. So all of these determinants, and just to solve for the variables, we use Cramer's rule. So to get x, it's determinant of ax divided by determinant of a. For y, determinant of ay divided by determinant of a, and so on. And this will just give us the solutions to the equation. So we put it in here, and we just say determinant of ax divided by determinant of a, and so on, and we print it out. It will give us the solution for x, y, and z. So the mechanics are super simple, but it's not very computational efficient to do it because getting the determinant involves a lot of difficult calculations in the background. So this was just to show you the mechanics this time, and thanks for watching. And don't forget to like and subscribe.